Section 6.1, simplest radical form. Okay, so we're going to start off with two fractions that you probably know fairly well, 1/3 and 2/6. I have pictures of them up here, dividing the egg carton up into three parts and saying I'm going to take this 1/3 of the carton. But here I'm dividing it up into 6 parts and saying I want this part and this part. That's 2 out of 6, but they're equivalent. Now, you're probably very used to these very simple equivalent fractions, but it does bring up the fact that we have different representations for the same number. It could get confusing. Not these numbers, they're pretty easy to deal with, but what about simplest radical form when it looks more like this? Who would have known that these numbers were all the same numbers? That is not going to be easy for people to quickly calculate in their head and make sure that if they get one answer or the other, they're really the same. So we've got to agree on which one of these answers is going to be our final form. So that's why we need simplest radical form. It's like saying 4/8 is equal to 6/12 because they're really both 1/2. But it's a little bit more complex than that. Now there are 2 rules, but it's going to feel like maybe a little bit more. The first rule we're going to deal with on this video, it's leave no perfect squares inside the radicals. Now our perfect squares are 1 and 4 and 9, 16, 25, etc. And how I get those numbers is I just take 1 and square it, I take 2 and square it, etc. 9 is 3 squared, 16 is 4 squared. So you want to maybe make a list of your first 10 perfect squares, maybe 12, maybe more, and then you can have that handy for figuring out the simplest radical form. Okay, so 12. Does it have a perfect square in it? It does. And you got to remember that this is like factoring and that it's all multiplication and division. So we want to think, well, what can we multiply to get 12? And you could start this any way you want. You could think of 3 and 4 instead of 2 and 6. That's fine. But what I'm going to do is I'm going to circle the prime number 2, but keep going with the composite number 6. What numbers can I multiply to be 6? Well, 1 and 6, but don't ever do 1 and something. You'll just keep going. So never divide by 1. Find other things. If there are no factors besides 1 in itself, it's prime. So 2 and 3. So the prime factorization of this 12 is 2 times 2, or 2 squared times 3. Now 2 squared is 4. Well, that's a perfect square. So if I take the square root of 2 squared times the square root of 3, that's the same thing as the square root of 12. And square roots and squares cancel each other. So we get 2 radical 3. There we go. 2 radical 3 is the simplest radical form, or radical 12 in simplest radical form. You could get a calculator and check that those have the very same value. Now, no matter how big the number is, this is a very quick process because division makes numbers very small very quickly. So I'm going to make a factor tree. That's what this is called. Okay, this right here is called a factor tree. And this is called the prime factorization. Alright, so we're going to make the factor tree. I see 9 and 5. 5 is prime. I could keep going with the 9. Some people see, wait, 9 is on my list of perfect squares, so I could stop there. Well, you can, and I'll let you do that, but it's more of a shortcut. So I put a square around the 9. So I would have the square root of 9 times the square root of 5. But what's the square root of 9? Well, the square root of 9 is 3. So I have 3 radical 5. Now, nowhere in there did I come up with the prime factorization, but I've got my answer. This is a factor tree. Any factor tree will do. If I start this over and I go, okay, I saw 9 and 5, but I didn't think about 9 being a perfect square, I could go further and say, well, that's 3 and 3. Well, there's your perfect square. Pairs are squares. Think about it. If I'm going to multiply something times itself, that's something squared. So 3 squared times 5, this is the prime factorization, and if I take the square root of 3 squared, I get 3. And I'll get that number right there again, just in a different way. Okay, a couple more. The square root of 72, like I said, doesn't matter if these get big. These could be 4-digit, 5-digit numbers, and all you have to do is find one or two numbers to divide it by, and it very quickly gets small. So I see this is 9 and 8. And I'm going to go further with 9 and say that's 3 and 3. And with the 8, I see 4 and 2. Out of all these numbers, prime, prime, and 2 is prime. 4 is not. We keep going. Okay, so here's a factor tree taken down where all leaves, yep, it's called a tree, and at the end we got the leaves. All leaves are prime, so I've got 2 cubed. Why 2 cubed? Well, there it's 2 times 2 times 2. 2 times itself 3 times is 2 cubed. But, you know, I'm really not concerned about cubes. I'm concerned about squares. So, remember, pairs are squares. So I really don't want anything larger than squares. So I could take that 2 cubed and make it 2 squared times 2. Now this right here is the prime factorization, but this is, I'll go further, I'll break this up more, because I'm taking the square roots and I'm looking for squares to come out of the square roots. Pairs are squares. So square root of 2 squared is 2. I'm going to go over here now because this is coming out of the radical. Square root of 3 squared is 3, and that does not come out of the radical. Now the two numbers that come out of the radical, they're multiplying each other, and so I get 6 times radical 2. Now I said in one of the other problems you could get out a calculator and check that, but there is another way. Think about what would I have to square to make this 6 go inside. Well, that would be 36, because the square root of 36 is 6. So this is my final answer, but as a check, you could be like, alright, I'm going to take that 6, I'm going to put it inside the radical, and it's going to become 36 times 2, and that's going to be square root of 72, and that just came out really, really messy, but I'm not going to rewrite it. Here, I'll just make that a 7. Square root of 72, not the answer, but just a check. 6 radical 2 was my final answer. Now, 4 looks a little bit more complicated. There's a number on the outside. What do you do with it? Well, not much really. It's just like over here when you had two numbers that came outside of the radical, they multiplied each other. Whatever comes out of this radical will multiply the 5. The 18, that's 9 and 2, and that is a square, and that's prime. So I've got 5 times radical 9 times radical 2. If you went further, this would be a 3 squared. Well, square root of 9 is 3. Not square root of 3, but 3. And it just came outside of the radical. It will multiply the 5, and I get 15. So 15 radical 2 is my answer. And I think we got one more, and then we are going to call it quits on this video. We're just going to do rule number 1 on this video, and then on the second video we'll do rule number 2 and then go a little bit further with it. Okay, so in this one I've got two numbers that are outside the radical, and we got two numbers that are inside the radical. The 2 will end up multiplying the 3, but I'm going to wait on that because other things are coming outside of these radicals, like in 8. Work off to the side. 8 is 4 and 2, and the 4 is a 2 and a 2. So 8 is 2 times 2 times 2, or 2 cubed. But 2 cubed is just 2 squared times 2. What I'm getting at here is I want to break out the squares. So times the square root of 2 squared times 2. So the square root of 2 squared is 2, so another 2 is going to come outside of that radical. So I've got 2 times 3 times 2. Now I know this 3, I brought it over here, and I could have waited on that, but it will multiply. So for the 90, a bigger number, but that's okay because you probably see right away it's divisible by 10. 9 is a perfect square. 10, if I keep going, it's a 5 and a 2. 9, if I keep going, it's a 3 and a 3. Prime factorization is 2 times 3 squared times 5. I'm going ascending order with the bases, 2, 3, 5. And I've only got one thing that's a perfect square, and it's this 3. So the square root of 90 is the square root of 2 times the square root of 3 squared times the square root of 5. Remember, this was a square root of 90, so all these things are inside square roots. So, stays inside, stays inside, stays inside, but this will come out. So, final, what I have coming out, this 2, this 3, this 2, and another 3. 2 times 3 times 2 times 3. Things that stayed in, this 2, and that 5. And now we multiply these things together, and we'll be done. 3 times 3 is 9, 2 times 2 is 4, 9 times 4, 36, and here we have 10 times 2, 20. 36 radical 20. Alright, come back and we're going to work on rule number 2 for simplest radical form.